Assalamualaikum warahmatullahi wabarakatuh. Uh, my name is Muhammad Hazimuddin bin Halif. My matrix number is DD190061, and I will introduction about the valve of our project. So a valve is a mechanical device that opens, closes, or partially obstruct channels or tubes to control the flow of fluids in many different fields and applications where fluid flow management is required. Valves are crucial components. There are countless varieties and specialized valves available for particular industry requirement. Okay, the condition where deterioration of metals and its properties because of reaction with its environment was stated as corrosion. There are a lot of cases or situations where corrosion can happen when it meets some of the requirement. In the fields of engineering, corrosion can have devastating effects as it makes structural material more brittle, lowering their capacity to support loads and jeopardizing safety. Mechanical parts can deteriorate due to corrosion, which causes more friction, wear, and eventually failure. In the case of valve, which been used in many different industries, including oil and gas, chemical processing, water treatment, and power generation, valves are an essential part. Here on the right, we have the application valve in a deep sea, and on the bottom, we will see the diagram of a valve, which include a stem, bonnet, plug, and the body, which connected to a pipe. So move on to the forms of corrosions. Leakage. Firstly, the frequent opening and closing that valves experience might harm the sealing surfaces and other crucial places. Possibility of leakage rises due to the continual exposure to seawater, exacerbating this wear and tear, resulting to the failure of open and close valve function. The second is the stress corrosion cracking, SEC, when in a H2S containing oil and gas production process, a situation where hydrogen diffuses into the alloy's anodic sides makes pressure reaches a specific point due to the accumulation of hydrogen atoms in this location. Energy is suddenly released, then the alloy becomes cracked as a result of this reaction. The third possible of corrosion is contamination. The rust and particles and corrosion scales are examples of byproducts that might result from the corrosion of valve materials in seawater.
There are several methods of inspection for internal X70 spring for subsea valve. One of the methods is dye penetrating testing. This method is used to reveal surface discontinuities by bleed out of colored or fluorescent dye from the floor and based on the ability of a liquid to be drawn into discontinuity by a capillary action. After a period, excess penetrant removed and a developer applied which acts as blotter that draws the penetrant from the discontinuity to reveal the defect. Other method is magnetic particle inspection. It is non-destructive testing method which detecting surface and near surface defect in ferromagnetic materials. It is particularly effective in identifying discontinuities such as cracks, lapse, and other defects that can affect the structural integrity of component. If there is a surface or slightly subsurface defect, the line of magnetic force will undergo deformation around the flow. Then there is eddy current testing. It is a non-destructive testing which used to detect surface and near surface defect in conductive materials. It works based on the principle of electromagnetic induction. Its purpose is to detect and identify flaws or defects within component. Using eddy current testing, we can find very small defect that might not be visible to the naked eye. There's also ultrasonic testing, which non-destructive testing that utilize high-frequency sound wave to detect and characterize flaws or irregularities in material. It can also be used to determine the thickness of a material. Uh, Ultrasonic testing is predominantly employed on metal materials due to their ability to effectively conduct and transmit sound wave, enabling accurate measurement through this method. When the material is defect-free, the sound wave propagates through it without obstruction. However, if the sound wave encounter a defect, they reflect off it, providing an indication of its existence. And lastly, uh, visual inspection. It serves as an initial screening method to identify potential area of concern. Inspection of the entire surface of the spring to find any indication of pitting or stress cracking corrosion. If indication of pitting or stress cracking corrosion are found, further non-destructive testing method may be employed to confirm and characterize the extent of the corrosion. There are some parameters that needed for the inspection to be performed, such as visual, magnification, lighting, and surface preparation. For the visual, we initiate the inspection process by visually examining the spring, aiming to detect any observable indication of pitting or stress cracking. We pay close attention to surface irregularities, discoloration, or the presence of the crack. For the lighting, we need optimized lighting condition to ensure adequate illumination, thereby enhancing visibility throughout the inspection. Sufficient lighting aids in the accurate identification of the surface defect. For the magnification, employ suitable magnification tool such as a magnifying glass or microscope to conduct a detailed examination of the spring surface. This facilitates the identification of minute pits or cracks that may not be discernible to the naked eye. And the surface preparation is uh, prior to the inspection, meticulously cleans the spring surface to eliminate any impeding element like dirt, debris, or coating.
Alright, for the next part is will be the standard of for inspection as a book and so the measurement. So the first thing is we would relate for the standard for inspection, and so the measurement is the National Association of Corrosion Engineer. We call it such NAS and ACE. So NAS is widely used to standard in the petroleum and also the natural gas sector for selecting and qualifying material environment contained in the hydrogen sulfide. Also, the standard address the challenge of corrosion and cracking. So the method is used the H2S, which is to contain environments such as sewer gas wells, oil and gas production facilities, and also refined. Also, the engineers and the industry expect the expert can evaluate the corrosion resistance of the valve material in the water applications. So by applying the principle and also the recommendation outlined in NAS, which is the MR 0175. Alright, so the last thing is the standard emphasize the importance of selecting material in specifying resistant to corrosions and cracking while considering factors such as the temperature, pressure, and also the exposure time. Right, so we don't forget about the International Organization for Standardization, which is we call it as the ISO. So ISO is an international standard that specifies the condition and method for pressure testing metallic valve. So the pressure testing is a crucial step in ensuring the performance and resistance of valve, that potential leakage and also the corrosion related problems. So it's provide the concept as and the current recommendations for the conducting pressure test on the metallic valve, including guidelines for selecting the test pressure, testing time, and also the acceptance standards. So for the seawater application for the valve, the corrosive condition can be compromised valve structural integrity and so the sealing capabilities. Right, so for the functional testing, help to identify the performance issues such as
inadequate the sealing and also the improper pressure release by the following criteria outlined in API. Industry expert can be systematically inspect the valve in the seawater application. So, and the last thing is the regular inspection conduct per the recommended practice can help to identify the potential problem, which is we ensure the regular maintenance and also enhance the integrity and reliability as a valve in the corrosion seawater environment.
Assalamualaikum and a very good day. My name is Muhammad Nazirul Amin Bizukifli and I will be explaining about the prediction for negligence of corrosion monitoring program. The first one will be the failure of equipment where the corrosion forming on the valve would degrade the valve integrity. The second one would be the safety risk, where the failure of the valve could pose a threat to the environment, staff, and the damage, where any corrosion could cause leakage and such. The third one would be compromising the valve reliability. Corrosion formation could lead to the reduction of valve reliability, which causes it to become more sticky and unable to be moved, which increase the odds of leaks or rupture along the pipeline system. The fourth one would be the environmental impact. The leak caused by corrosion could cause hazardous liquid to spill to the environment, causing environmental damage. Another prediction would be the costly repair and replacement. Damage caused by corrosion could lead to costly repair, which include the maintenance and also sudden repair of damaged part, damaged system, and also the damaged pipeline. In addition to that, leakage could also lead to costly compensation, which is due to the environmental damage, to the damage and injury cost to the staff, and also to the maintenance and also the facility. The last one would be the halt of production. Due to the sudden maintenance, could halt the production, which would mean that the decrease of revenue and potential financial penalties due to the company not being able to meet the production of the clientele. Next, I would also could talk about the affected parameters due to the negligence of corrosion monitoring program. First of all would be the effect of fluid flow of transported liquid. Corrosion could restrict or hinder the flow of smooth flow fluids, which lead to increased friction, turbulence, or even blockage. This is because the buildup of corrosion within the valve system could cause additional blockage and also would mean that less area of the pipe can be used. Next would be the deterioration of pressure integrity. Corrosion can weaken the integrity of the valve, which reduce its ability to withstand high pressure. This is because of the constant high pressure within the piping system, which also includes the valve. Due to the corrosion, which decrease the area and also increase the pressure, which meant that because of that, the deterioration of pressure integrity is possible. Next will be the valve functionality. The corrosion buildup could affect the operability of the valve by making it harder to open and close. Next will be the formation of crack, gaps, or holes due to corrosion. Could result in product losses, environmental contamination, safety risk, and decreased system efficiency. Lastly would be the valve lifespan. Neglecting the corrosion formation could lead to the degradation level of the valve, which means that due to the corrosion, it will become less sustainable for long-term operation. And I believe that is all from me, and thank you, and have a good day.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shazwani binti Mohammed with matrix number of AD190079. So I would like to present about the question 7, which is predict the material of construction MOC to respective failure due to the presence of seawater and the chloride containing environment. So firstly is stainless steel, austenitic and duplex. Due to its exceptional corrosion resistance, stainless steel is commonly utilized in marine applications. Next is alloys with a considerable proportion of nickel. Inconel and Monel exhibit strong corrosion resistance in seawater and chloride condition, for example. And then titanium and its alloys resistant to corrosion in water and chloride conditions. So next, fiber reinforced polymers (FRP). So they have great corrosion resistance, are lightweight, and have outstanding mechanical qualities. Lastly is coatings and linings. It can be an effective approach to protect materials against corrosion in seawater and chloride environments in some instances. For the question 10, we have to suggest for the characterization of the damage for pitting and chloride stress cracking corrosion. Firstly, we suggest a visual inspection as it entails inspecting the material surface for apparent symptoms of pitting such as small pits or localized surface damage. Next, optical microscopy, which can be used to determine crack morphology and crack networks caused by chloride stress cracking corrosion. Next is SEM. Scanning electron microscopy can reveal pit morphology such as shape, depth, and distribution. Next, energy dispersive X-ray spectroscopy (EDS). It can aid in determining the presence of chloride ions in coral areas, which is critical for comprehending chloride-induced corrosion mechanisms. And lastly, electrochemical techniques effective for determining a material's susceptibility to pitting and chloride stress cracking corrosion.
Alright, so I would like to share with you for preventing and also the recommendations. So the first thing is authentic stainless steel, which is such a grade as T316 and 316L. So the advantage of using these things is the high concentrations of chromium, nickel, and occasionally mercury are found in the acetic stainless steel, which has helped to prevent corrosions. Also, membrane increase the resistance to chloride condition, including the seawater. They still resist pitting crevice, which is the general corrosion in marine environment. So another choice for maritime application is the duplex stainless steel, like the grade 22005. Right, for the last thing is to generate a catalytic environment that reduces the corrosion, use the catalytic protection as well. Technique like cyclophile anodes or impress the current system. Um, with this method, a metal can that corrode more readily is used to shield the valve from the corrosion brought on by the seawater. Also, the last thing is to reduce the salinity, regulate temperature, and also the pressure swing. We use the water streamer method, which is to improve the environment. By taking these steps, I think the corrosive will be effect of the seawater on the valve can be reduced.